Asset data management and data classification. This module focuses on few topics related to asset data management systems, significance of the asset database in the efficient management of the total assets, various categories of data collected, and types of the information systems mostly used in the region. The key aspect of asset management is efficiency in data management. This is not possible without an asset database. Data do not need to be stored in a sophisticated information system. Database format is less important than their content. The public utility company's staff and the local self-government must understand the value, significance, and need for accurate and relevant data for an asset management system. How these data are organized, analyzed, and utilized is equally important. Infrastructure asset data include general information. 1. Asset register, usually referred to as capital or fixed asset register. 2. Information on asset characteristics such as manufacturer, model, serial number, year of the first use, capacity, etc. 3. Spatial information on asset location or in relation to other assets and the whole system. Such data are usually contained in a geographic information system. 4. Intrinsic information about assets such as performance, condition, life cycle expectancy, maintenance alternatives, and similar. 5. Data on planned long, medium, and short-term maintenance activities. 6. History of previous maintenance activities and experienced failures. Finally, important pieces of information on infrastructure asset are obtained from various documents, drawings, maps, or photos of the assets. Availability of information is crucial for adequate decision-making on asset management. Information such as optimal maintenance frequency and renewal of assets, maintenance costs, failure and condition probability are required to make a decision on a new repair or possible replacements of that asset. Access to this information is another important thing for efficient performance of the public utility company. On the other hand, asset management represents a certain cost for the PUC. Apart from data collection, registering, and storing, there are some hidden costs as well. These costs can be expressed as the time required to obtain necessary information, processing of information collected from various sources and in various formats, repetitive activities which occur due to diverse needs of different beneficiaries and business processes. The obvious, predictable costs make only 20 to 30% of the total asset management costs. Development of a comprehensive asset information management strategy can reduce the hidden costs if it is compliant with the asset management strategy, describes the methods of collecting, storing, maintenance and management of data, as well as the method of utilization and analysis of data. Initially, several questions should be answered. 1. What information are needed and why? 2. How to ensure the quality of information. 3. How to handle inadequate information. 4. What type of control over the data collecting, storing, maintenance and management should be applied. 5. How to ensure that all users of data have a required level of understanding the significance and role of information during the asset's entire life cycle. 6. What information and other technologies should be used in asset data management. 7. How to make the most benefits from the available system and processes. It is important to start the process of data collection by determining what kind of information is needed and why. To answer this question, one should look at 1. Data on user structure, because various types of users need various data, and 2. Difference in data details and objectives, depending on the senior or lower levels of decision-making or various needs of different users. The range of data uses is very wide, starting from direct participants in the operational activities that may be senior or lower-level decision-makers to external users, such as the founder, regulatory bodies, partners, scientific and professional organizations, the general public, etc. It is important to understand that basic data are always the same, coming from unique database, and therefore must be consistent, always ensuring a single version of truth. It is only the form in which they are presented to different users and the way they are combined that differs. Additionally, there is a principal division of infrastructure asset data into 1. Strategic data, used by the senior management and key decision makers. 2. Tactical data, created and used by the technical planning management. 3. Operational data, created and used by the operational and technical staff. Each business process should be managed by a special team who will request and acquire specific data in line with their needs. Data management will be more efficient if an appropriate organizational scheme is linked with the diagram of each business process and if critical points are identified for each process. During the process of identification of requests and needs for collecting asset data by the science team, it is of utmost importance to establish a detailed specification of the required data and classify them in general groups of data. Also, it is necessary to determine other aspects regarding frequency of data use, characteristics or attributes of specific data, accuracy and precision of information, that is, to set the level of tolerance of inaccurate, incomplete and unreliable information. Collected data need to be verified, compiled and classified. Classification is done according to the hierarchy principle. This ensures adequate decisions during the prioritization process, depending on the significance and position of assets in the system. Basic criteria of classifications are 1. Functionality of assets and 2. Type of assets. Classification criteria directly define the method of data storing in the asset management system and directly shape decision-making processes. Assessment of collected information on assets is a complex process that should be repeated and used in A. The process of needs assessment of data users. B. The process of redefining the necessary data to be collected. C. If the costs of information collection and storing are found to be too high and do not pay off, it is necessary to redefine the needs and requests for data collection and repeat the assessment. During the assessment of availability of collected data, it is very important to answer the following questions. 1. Are the necessary data collected and stored? 2. Are the collected data complete? 3. Is there an adequate history record of data? 4. Is there a correlation amongst various groups of collected data? 5. Are collected data easily accessible? If most of the answers are yes, the data assessment is continued and their quality determined. However, if the answer to the majority of the questions is negative, the reasons for such findings should be identified. The problems must be eliminated and the assessment of the asset's quality continued. Accessibility and accuracy of collected data affect efficiency of an asset management system. If data are more or less available but lack accuracy, they cannot be a reliable basis for decision-making. Data quality assessment is the most complex and the time-consuming activity. It is not a single-time activity, but a continuous process involving people, procedures, and use of information systems. The following is essential for the good data quality assessment. 1. Anonymous interpretation of data. 2. Consistency. 3. Accuracy. 4. Integrity. 5. Understanding of data specifics. Data quality assessment process includes definition of activity and plans for elimination of identified deficiencies, assessment of how the identified deficiencies affect data quality and overall decision-making process, risk assessment in regarding the entire asset management system, assessment of costs of deficiency elimination process. Measurable performance indicators for data quality assessment include the amount and extent of collected information, degree of completeness of an entire group of data, percentage of accuracy.